latitude for various, there is latitude here for various ideas, and the ideas that I'm presenting here are my perspective. So other people may have other ideas, and I welcome those. As long as at the end of the day, you're looking after the craftsmanship and the quality that originally went into these movements, and then you leave the movement, kind of like the Hippocratic Oath, if you will, do no harm and only improve things, then that's fine. But what worries me is when things get done to these movements that profoundly damage them for future generations, or make it so that the next time they get serviced, there's an impossible task ahead for the folks that have to work on them. All right, so kind of as a preference, some of the things that I've heard over the years, American clocks are they're too cheap. There's no point in doing anything with them that takes any time. Throw them over to the apprentice bench and let him mess with them, get out the solder torch and whatever else. If I could share with you some of the things I've seen in these movements, it's horrible. As long as the clock runs when you're done, it doesn't matter how long it runs, as long as it runs. And the other one, of course, which is one of my favorites, is just keep a whole big, like you see on the right side of this slide, keep a long and extensive stock of old movements. And you could either steal the movement and put it in, or for that matter, just rip it apart and take parts out and put it in another movement. Now, one of the problems that I have here, I don't know if it's a problem, but it certainly is a concern, is I don't want to step on anybody's toes in this chapter, because I don't know anyone in this chapter really. I don't know your level of experience with these things. So if I don't mean in any way to talk down to anyone about these issues, and I apologize if it comes off that way at any point. And of course, you can always, call me on it if you like to during the presentation. And, and again, it's not yet the intention. But what I do encounter with these movements are, things like Rathburn bushings, soldered up little pieces of metal with holes drilled in them, soldered to the plates, punched up holes. Oh my goodness, it is the worst thing to try to deal with, punched up holes on a movement. Incorrect or oversized mainsprings, the wrong suspension spring, really important wear elements that just get neglected, and substitutions, parts that end up in the movement that absolutely don't fit or are the wrong part, but somehow they kind of got in there. I just worked on a movement recently. In fact, it's one of the ones in this presentation. And someone had fit a new main wheel on the time side, and it was literally a ½ inch shorter than the strike side arbor. So, and that kind of thing is like, oh my goodness, the key barely fits, the key's rubbing against the dial when you're trying to wind it. Anyhow, so those sorts of things they're just not good. And whoops. So I think, in my opinion, American clock movements are works of art in their own time. And no, they're not, German-made fine craftsmanship movements in the same sense, but they work. And they last 100 years. They've lasted over 100 years now. Many of them even 120 years, 130 years. So they're worth it. And your customer might say, well, I don't want to spend that much money. Maybe you should spend a little time educating your customer as to why it would be a good idea to do the job right. And so, one of the other things is that there's a lot of parts out there from the suppliers that don't fit. And you might think they fit because they're called the same thing, but they don't. And so kind of be on the lookout for that. Another thing that I've learned the hard way back in the early days is polished pivots always last longer than if you just put the thing back together again. Look at the power that's being supplied by these mainsprings. If you don't have smooth pivots, you're not going to have holes anymore. They're going to wear right through. And I've actually seen it. And so I like to go through the process of glass smoothing with burnishing. And I don't do the hourglass pivots and just fit extended bushings and hope that it catches it. That's just poor quality, and it cheats the customer out of a good job. Rathburns, of course, as you all know, just permanently deface the movement, and you're drilling holes in a movement assembled, which then results in particles of brass ending up in precarious places too. So, and we'll talk about the mainspring things a little bit further on. A lot of folks just neglect the wheel bearings on the main wheels and the ratchets and clicks, and then holy smokes, look out, your customer ends up with broken, damaged or bruised knuckles. So there's also, you know, kind of a personal safety thing in here if it's not done right. So always be aware of that and the impact of your work on the customer. So here's our host clock today, and we are going to get, as it says at the bottom here, we're going to get some special appearances by a New Haven 300 series time strike too, because I found that to demonstrate everything I wanted to, I couldn't do it all with just one movement. So there's a little bit of a blend here. But this story behind this one's interesting. I had an apprentice in when I was in Austin, which was like from 2000 to 2015. We lived in Austin. And I was fortunate enough to meet a fellow down there who wanted to do some apprenticing, and he impressed me for some number of years. So now when I go back there, I visit with him, and he sometimes saves his troublesome movements for me to, you know, kind of help him work through. And this was one of them. This was one of his trouble clocks, as he called it. And he just couldn't get the clock. He just couldn't get the clock to run. And I looked at it and, oh, okay, here's the problem. We have to get the verge adjusted, right? So we have proper lock on this thing and the proper drop on it. And so we did that. And, you know, I was proud of it. You know, it's it. I see, that's not so tough, Jay. This is a workable problem. Ran the clock for a day before I left to go back to Colorado. The clock stopped. So, and there was nothing that we could do to keep it running. So I just told him, pack it up and send it, and I'll take a look at it. And boy, am I glad he did, because this thing was loaded with problems, just loaded with them. And so it made a good subject for this discussion. Now, you know, before we go too far, the thing that we want to do is we want to do the cleaning on the movement. And it turns out that you know, way back when I was, you know, learning things, back when I was 14, 15 years old, my mom took me to a guy in Cleveland, and he's long since passed. But what he used to do is he used to take the clocks, wind them down, and put them in crocks with ammoniated solution, and just leave them in there overnight, take them out, run them underwater, blow them out, and put them back into use again. Well, you know, the problem is that you didn't disassemble the movement. Now you've got a whole mess of problems that you've created. And so my recommendation is, you know, disassemble. Don't clean movements fully assembled that are 120 years old and have any hope of being able to get the thing to operate properly for the long term. But the good news is that American clocks really do respond well to ammoniated clock cleaning solutions. And here I have ammoniated solutions. I also use a product called Xena 777, which is really great for cleaning parts that are not compatible with ammoniated solution. But you don't find those parts generally in American clocks, very few exceptions, but generally you don't. So that kind of works out conveniently for us. Usually you'll find that the trundles are loaded with dirt. They're often packed in, and tons of dry oil in there that has accumulated over the years. But regardless of that, I'm not at all a fan of keeping any movement in the tank longer than maybe 30 to 45 minutes. And the reason is because the ammoniated solutions do go after the copper in the brass. And if you leave them in there too long, you're going to start to deteriorate or even etch the brass, even visibly. And so, and I've seen where, you know, I've myself lost parts and didn't know they were in the tank, took them out 2 days later and looked at the part and said, oh, for goodness sakes, this part doesn't look anything like it did when I put it in. So you have to always be careful. Now, as a routine, I go in there and check to make sure that there's nothing left in the tank, because I run my tanks at about 40 degrees C, and you combine that temperature with the chemical solution, and you're going after the brass. And I did a cleaning presentation a while back where I did an analysis of how much brass is lost. And if you only keep it in there for 30 to 45 minutes, you only lose maybe, you know, 30 to 50 nanometers of brass on the surface, and it's not a big deal. Now, if you do that 20 times, it starts to add up, but you know, any given cleaning won't do a substantial amount of damage if you minimize the time that you're in the solution. And then I also recommend rinsing main wheels in IPA or naphtha, just to get the water out from underneath those you know, those assemblies, they're pretty tight in there, and you got to get, you want to get all the water out, or else you will have, you know, secondary issues occur down the road. And then of course, the other thing that helps a lot is use compressed air, blow everything out, just clean all of it out. Wear ear protection when you do that, because I'm sure I don't have the same hearing I did anymore because of the the abuse that I've you know, exposed my ears to over the years, including using compressed air without ear protection. So I just want to share this with you really quick. This is from a presentation that we did a while back in a workshop. There's a really nice formula for ammoniated solution. I've used pretty much over the years every commercially pre-mixed solution that's out there, and they're all good. I mean, generally they're good if you use them correctly and don't abuse them. You get pretty good results. But every so often you might be like, oh, darn it, I want to clean some clocks and I'm out of solution. What happened? Well, if you keep a small amount of oleic acid around, which is the only maybe difficult thing to get out of this whole set of formulas, you're good. You can make up a nice, long-lasting solution based upon this formula. And since we're recording it, folks can look back on this later if they want to see it, or I can send it to anyone. You can email me and I'd be happy to share it with you. But this solution is my go-to, and was my go-to during the time when I couldn't buy my favorite, which was Reindel. Although I finally caved in and bought some LNR and used that while Reindel was trying to reformulate. But now Reindel's available again, so it's good. But this solution really works really, really well. The other thing that's I think is absolutely key to getting a good, you know, clean movement is brushing with a brass bristle brush, every part. And the nice thing about brass brush is it will not mar the plates. It won't scratch. It just takes off the contaminants, the dried on finger oils, the oxides, all that just goes away. Sometimes you have to rinse, lather, and repeat on it. You got to, you know, do multiples, like you soak, take it out, brush, put it back in, take it out, brush, rinse it off, dry it, and you're good. But it does take a little extra work, but it is so well worth it. And after you get good at it, it's like no big deal. So anybody that thinks they can put a movement disassembled into an ultrasonic tank, I find that the ultrasonic action does help break up some of the dirt, but it does absolutely nothing for the dried on, difficult to get off finger oil or whatever it might be that's on the surface and is accumulated there. In fact, it actually, you know, bakes it in further if you don't do something to get it off. So ultrasonics are great, but they're not the end all that a lot of folks think they are. So here's some brush options. I love these Torrington brushes. They're really good. They're big brushes, and they pass over every, you know, obstacle on the plates or the wheels or whatever, and they can help you really do a good job. Wear gloves, of course, when you do anything with ammoniated solutions, because they will dry the living heck out of your skin if you don't. So moving on past the cleaning, then we know that we need to do proper pivot polishing. We talked about the importance of that earlier. And of course, a rough finish on a pivot will, and the story I tell people about this is the movement that I did back in late 80s, early 90s, where I replaced bushings, and I got on this kick of using bronze bushings, thinking that they were a whole lot better. And so I didn't do the proper job of pivot polishing, put this thing together literally before I sent the client. It was on its test run. And literally before I was able to send this thing back to the customer, thank goodness, I looked at it and noticed that the second wheel rear was just completely, the clean oil had turned into black sludge from just a few weeks. And so I took the whole thing apart and learned my lesson forever after that. Polish the pivots. The other thing that I like to suggest folks do is break the tip of the pivot. Now, I don't mean break it off. I mean, in the sense, I mean, get rid of the nib. When they machine these movements back in the day, there was always from the parting tools, they always seemed to leave these little nibs on the end of these things. And you know what happens when you go to reassemble the movement? We don't have all the fixtures they used when they assembled these movements back then. They used fixtures that would allow all of the wheels to be held upright while they drop the plates on. So boop, in one step, everything went right in. Well, we don't have that. What we have is we're fiddling around trying to move these wheels around from here to there and trying to get them worked into the holes. Well, the process results in huge scratches on the insides of the plates in the process of doing this. Well, you think, well, so what? Nobody's going to see it. Well, yeah, they will. And here's why. Because what happens is that metal that gets scratched off ends up in your pivot hole. And unfortunately, then that yields wear much earlier than you want. So if you polish the tips of these things, it takes 1 or 2 seconds to do it. You don't have the problem with scratching up the plates later. The tips of the pivots glide over the plate and drop in. And it also makes it easier to put together, obviously, from that. So something I would suggest is just knock off those nibs. It takes a second or two to polish them up and you're good to go. So what I use for polishing pivots, and I know everybody has their favorite, and as long as the pivots are smooth and clean and flat and cylindrical, you use whatever method you want. But this little tool here does a heck of a job. One is left hand, one's right handed, depending upon which way you like to work. If you like to work under the pivot or over the pivot when you're working on it, but it does a great job. I would suggest do not use a regular file ever, because regular files will scratch the living heck out of the pivot, and then it takes a lot more work to get a polish on it. But if you use this tool, you get great results. And then, the thing about burnish, a lot of people get confused on burnishing and say, well, burnishing doesn't work. Well, part of the reason it doesn't work is because folks don't know that you have to dress the burnisher multiple times during the pivot polishing process. In other words, you start the pivot polish and then, the burnisher actually wears out. You have to go back to the 120 to 150 emery paper, restroke the burnisher, and continue on your way. And there's a lot of controversy over whether or not you use oil. Man, oil, I think, just helps a whole lot, and you get a much nicer job. And you could use something like transmission fluid to do the oil. It doesn't have to be anything fancy, and you'll get a nice burnish. And again, it's probably going to be a rinse, lather, and repeat to get the burnish up to where you want it. You can use your fingernail to determine if there's any rough spots. And one of the things I found works, especially on really large pivots, is after you've gone as far as you can, if you take a little bit of Flitz metal polish on a popsicle stick, you could really impart a dazzling mirror-like finish on the pivot. And now you got something. You, of course, clean all the Flitz off, but you got something that'll last quite a long time once everything's done. So here's an example. On the left, you see it before, and on the right, same exact arbor after pivot polishing. And so the one on the right is going to outlast the thing on the left by a long shot, no question about it. So, and the whole thing takes maybe a minute or two to get a good job, including getting rid of you see the little bit of an hourglass effect taking place there on that pivot. So this is not uncommon in these clocks. So after we have all the pivots polished, we want to go in and we want to do all of the inspection to see where we are in terms of our wear and so forth in the holes. So you want to completely not completely. You want to reassemble all the train wheels and the main wheels. You don't need to put all the levers and then the strike arm in there, because you don't usually see a lot of wear there, although you may, and if you do, you could always check those later separately. So and you don't want to neglect polishing the pivots on those levers either, by the way, because those do get pretty dull over the years. So what we do here is we're going to look for hole wear anywhere where it might exist, and we want to inspect the verge hole and the verge faces as well, and of course the trundles, which you should be able to see those without assembling it, but it always helps to kind of look at it all at once. Here's some of the things we found on this particular movement, and you can see there. One of the things that I strongly suggest you do is use a Sharpie to mark what you're doing. Do not scratch on the plates. I think that just defaces the clock horribly. I've seen people not only scratch the mark where they want to pivot, but also rebush, but also write down into the plate the bushing they're going to use, which is like, come on, do we really need to do that? If you're going to do that, do it with a pen. Don't do it with a scratch all. It just defaces it. On the right's an interesting one, and it unfortunately doesn't really, whereas you could see the wear here on the left and middle. You can't really see it in this photography, but that verge was so loose on that pin. It is amazing it worked at all. It was just all over the place. And so we have to address that, and we'll talk about that in a minute or two here. But don't neglect that. Always look for that too. And it's really hard to rebush the saddle on a verge. So we're going to talk about what we might want to do there. All right, now we get into one of the more controversial aspects of this. And again, I don't mean to talk down anybody. I'm just presenting my perspective on this and what I've learned over 40, 50 years of doing this craft. These clocks often have very thin plates. 50 thousandths is not atypical. And as a result, it's difficult to get a typical, KWM or Bergeon bushing to stay in there, and let alone find the right size for these plates without ending up with practically no bearing area inside the hole. So the other thing is, often we have close clearances to the edges of the plates in these clocks. It's insane how close some of these were drilled. And so if you use large bushings like you find in the Bergeon kits, you could actually break out the edge, and now you got a big problem. So you don't want to do that. And my recommendation, and not everybody is going to agree with me on this, learn to make your own bushings. And I'm actually going to talk about that a little bit. It's not hard. And if you really are reluctant, only use KWMs on these clocks. In fact, I'd recommend never using Bergeons ever. They're just, the OD to ID ratio is just so large that it's extremely rare that you have to hog out that much brass just to rebush a little hole. So I really am not a fan of Bergeon, never was. I tried them, I hated them, and I dumped them. And we'll talk about that a little bit. Back about 25 years ago, I tried, folks. I really, really tried to make a bushing tool work, and I never was successful. The tools are sloppy and inaccurate. I tried the Bergeon tool, it was no better. When you get down to it today, a bushing tool is way more expensive than a lathe. The Shoreline lathe you can buy for about decent kit to get started for about $700. You're starting out with a Bergeon bushing tool at about $1,200. So to me, it's a big, enormous waste of money. And here's why. The reamers are poor quality. They're too small or they're too large. You buy them and you try to use the bushings are loose when you're done. It's crazy. It just doesn't make any sense. So the other problem is a lot of those reamers are dull. So you go in there and you get this big burr thrown up that you can't get rid of. They have a burr removal tool, but in order to be able to get rid of the burr that's thrown up by those tools, you practically have to cut half the plate out. So they're just awful. And then the other thing is that the pushers and anvils on these things are rough and unfinished. So what you're doing is you're imparting, you're making a mess out of the plates when you use the tool, on top of ending up with a poor bushing. So anyway, so you can tell here, I'm pretty adamant about it, but I realize other people are going to disagree. But the other problem is the bushing kits are hit and miss, especially when you're dealing with these thin plates. And with American clocks, sometimes you don't have oil sinks and you can't afford them because you lose too much bearing surface. So you want to look at it from a cost perspective. A 225-piece Bergeon kit is $103. And when I did the math on it, if you place those bushings end to end, allowing for some waste due to part off, that's $5 worth of material if you were just to go out and buy some 360 rod and use it instead. So, I mean, from every perspective I can think of, bushing tools make no sense. Now, here's the thing. A lot of folks get into clock repair, and the first thing they do is go hunt down a bushing tool to buy, because obviously every clock guy has to have a bushing tool. I'm here to tell you, I don't have one, and I'm bushing day and night. And the bushings, well, we'll see what we can do with them. Whoops, sorry about that, folks. Here you go. So here's why I like fabricating my own bushings. If you look at this picture, it kind of tells the whole story. This is with the same size ID, the same size pivot. You can see the OD on the Bergeon, the OD on the KWM, and the OD on a fabricated sleeve bushing that you can make yourself in the lathe in about a minute and a half. So anyway, it's just, I mean, you can usually start with about OD equals 1.5 times the ID, and it gives you plenty to deal with almost any wear you have. Now, obviously, if your wear goes beyond that, sure, you need to make the bushing to deal with that. There's nothing you can do. But in most cases, in most pivots, in most wear, the OD doesn't need to be all that big. So why hog out half the plate when a little sleeve bushing that, is virtually invisible will do the job? So that's the question I leave you with to think about. And so here's some examples of some bushings that were done on our infamous Ingraham clock. And you can see they're very barely visible and not intrusive. And especially here on this upper left, you didn't have a lot of room to work with there. And that bushing is in no way going to compromise the strength of that corner at all. So, and the other thing is the process of installing these bushings results in a bushing that's riveted and work hardened. You can replicate the original oil sink, or you can choose not to have any oil sink, which is often the case on these. This is what you need often on these clocks. This methodology is hundreds of years old. This is nothing new. This has been in work for centuries. It long predated box bushings, long predated it. And once you learn it, and I understand there's a learning curve, but once you learn it, it's just as efficient and fast. You don't need to set up a plate in the dogs. All that nonsense is gone, and it goes together fast. It eliminates the protruding bushings, the loose bushings. And also, by the way, I mean, if you really do like using box bushings, you can always put them in the lathe, modify them to the length you want, and you're going to be in pretty good shape with that method too. So if you do like using KWMs, I mean, you could even use Bergeons if you put those in the lathe and bore them out to the size you want to keep the OD to ID ratio down. So there's ways of using them if you're already in the process. Yeah, and if you already have a collection and you're happy with it, but I would also, going to do that. I also suggest finding another way to remount the plates and polish the living heck out of the pushers and the anvils on your tool so that you don't mar up the plate when you use the tool. So we're going to give you an example here, and I'm going to jump from between a couple of different clock examples because I unfortunately, sometimes you start taking pictures of things after you've gotten too far into the process, and sort of what happened here is, so I had to go back and find some other worn plates to use to show you the process. So here you can see it's clearly, this is an oval situation where the hole is worn, needs something done to it. And now here's the kind of imagine in your head here. What we did was we had about the same wear in this plate in this particular location. So we put an arrow in turn to mark which way we had the file in order to get the hole back to center. So we did that, and you got to use a little bit of technique to get that. And let me tell you, I promise you, if you put this in the dogs on a bushing tool and you use the pointer to tell you where you think the center will be, that tool will wander off and you will end up with a hole that is in the wrong place using your bushing tool. I guarantee it 100%. Which is why I don't recommend using a bushing tool. So here we file out the hole to center. We give it a couple of turns with the broach to clean it up. And you go a little further if you need to in order to get the OD to what it needs to with a broach. You don't need to go much further than that. And then, so we turn up our little bushing on the lathe here. You can see I could use a Sureline or I can use a watchmaker's here. I just chose to use a watchmaker's because for me it's easier and faster, but whatever, it doesn't matter. You could use whatever lathe you want, part it off, take the bushing, take a simple punch, a simple flat end punch. Now, one of the things I want to say about this, if you don't mind, is that always keep in mind that when you use a punch or a hammer or anything else to drive or rivet or in any other way impact a plate or any other clock part, always remember that the finish that's on that tool is going to end up on your clock part. So that's why first thing I do when I get a set of punches is I polish the faces to a mirror finish. Not hard, doesn't take long. And now I know that when I go and I drive this bushing down into the hole here, I'm going to have a bushing with a nice finish on the end of it. It's not going to be crummy and cruddy and marred. It's going to be clean and, in fact, actually look better than the plate around it, which is kind of a nice thing to see. So here we have installed the sleeve. And actually, some people will say, well, I'll just, put a chamfer on that and I'll be done with it. And that's okay. But what I tend to want to suggest is that you use a ball end punch, perhaps from your watchmaker's kit. This does not take a lot of force, so it doesn't damage the tool. And all you're doing is giving it a tap so that you're giving a little work harden to the bushing and imparting a nice, clean, attractive oil sink as well. So, and just a light tap. We were in the lathe class yesterday, and one of my students came and said, I just use this center punch tool. And I'm like, oh, I cringe, because that, while it might work, that center punch tool is not finished. So if he had polished that center punch, okay, maybe that would work. But the problem is that you can't control the angle on the center punch, and the ball end punches give you a much nicer, much shallower oil sink, which is much more like what was there originally. So here you can see at the end of the ball end punch, yet on the left, you could quit there. You don't have to go any further, or you can use the Bergeon 1897 Burnisher countersink tool, or, they make some really nice ball end burrs too that you could use with your fingers. Don't use them in a tool because you'll end up with chatter and it'll make a mess. But if you just turn them with your fingers, you can do a nice finish that blends the original oil sink. You can't even tell you were in there. So, but you could end it at the left side. That's fine too. I mean, it's kind of what you prefer to do. But the really good news here is the bushing is not sticking a 1/4 inch up above the plate, which is just, to me, it's terrible. And, the other thing you have to remember about that is if you don't choose the right length bushing out of a kit, what you end up with is a bushing that might be longer than the pivot. Rarely on American clocks, I know, but because some of those pivots are so long. But on many clocks, you could end up with tunneling, where the pivot will tend to wear its way into and underneath the bushing, and that can lock up a clock in no time flat. So it's a real hazard to just ignore that and make the bushing too long. So here's an example of one of our bushes with everything in place. We have the polished pivot there, and you hardly tell that bushing is there. Here's some more examples on our other clock. It was zoomed in. Pardon my photography. I got this. Some of these pictures got a little grainy. These bushings actually look better than they do in the pictures, but you get the idea. All right. Now, if you haven't all signed off by now on the bushing issue, which I know is very controversial, maybe we can move on to suspension springs and rods, which hopefully will be of help to you. I've rarely these days, it wasn't like this back in the 70s, but it is now. It's rare that you end up being able to work with an original suspension spring, because by now most of these things have been broken, mishandled, dented, bent, whatever, and they're just not useful anymore. And unfortunately, as hard as I've looked, I haven't found a lot of data on the original sizes of these things. So much of what I'm going to propose here is based on observations that I've made over the years on, when I have run into original springs, which you can really tell they're original because they're real high quality, which the new ones are not. So there were a number of styles. And my experience is that the new replacements that you can buy are as close to garbage as anything I've seen. You end up with sloppy assemblies. You end up with incorrect dimensions. I've actually, seen feathers come to me brand new out of the box, cracked. The rod's deformed, rust all over. Here's an interesting one. The hole that the little wire is put in there to act as a stop, for when you mount it in the block, it's out of center. And it's like, how hard is it to just get the hole in the right place? I mean, it just seems weird. And you can see, I've actually seen some of these things on Amazon, and they're just an atrocity. I'm sorry. They're just terrible. So some observations, with rare exceptions, and by rare, I mean, so talking about a very long case clock with a pendulum that might be a foot long or something, pendulum rod a foot long. 004, anything over 004 is rare and problematic. So with some of these mantle clocks or kitchen clocks with short pendulums, if you find a 006 or something like that suspension spring, that's going to be a problem. Those clocks just don't have the power to run it. And most of the time, the bobs are so lightweight that 004 presents too much resistance to get the performance out of it with the very light amount of impulse that you get from the escapement. So, and I've seen all kinds of these things. And as soon as you see something that's bigger than 004, you basically should look close because something's wrong there. Many of the earlier springs that I've run across originally were 003 thick, 1/4 inch wide, and about 1/3/8 inch long, although the length does vary. And most of the replacements today are 004 by 1875 by 1 1/4. And this is just not the same. And it very much does not work properly. Now, you can go and like we here locally have a fellow that runs Mile High, great guy, and he sells feathers. He sells just the feathers, and you can get those all the way down to 002. But the problem with those is they're usually 1875 wide and 1 1/4 long, which doesn't fit with many of the original clocks. So you have to be careful. And so I found, unfortunately, that sometimes I have to take the 20 minutes that it takes to fabricate a brand new suspension spring that fits exactly right. Unfortunately, suppliers don't tell you a whole lot about the dimensions. All you know is how long the wire is, and that doesn't really help here with trying to fit the right spring. So getting back to our Ingram clock, some of the things that I ran in with this clock is I actually had trouble getting the clock to run, even after all the other problems were solved with the wrong suspension spring that was in there. And I show you there on the left, the one that was actually in there. It was actually 006. Like it just literally stopped the clock. It would run for a little while and it would just stop. When I got the clock here originally, it had super strong main springs in it, and so it was able to overcome that. But when I put the right thickness spring in it, it couldn't. And probably after it wound down halfway, it wouldn't have run it anyhow. So it was, all the same, it needed to be taken care of. The other problem you run into is wobble. And pendulum wobble, I'm sure everyone has seen it, can really be a serious issue because it robs power from the escapement and causes problems with the clock running either throughout the entire length of the 8 days or keeping good time. You could have either one affected by wobble. So you don't want your pendulum wobbling. And we'll talk more about that in a second. But so the right spring, it turns out for this Ingram was 003 by 1/4 inch by 1.375. Although I did try the 003 by 1875 standard replacement, 1 1/4 length, and I had so much wobble, it was almost funny to watch. So that one didn't work. And then take a look at that, how subtle a difference that is. You go from 1875 by 1 1/4 long to 1/4 by 1.375, and it eliminates the wobble. And I don't have a good formula for how to eliminate wobble. All I can tell you is if you use the original spring dimensions, the wobble problem will not exist. So sometimes it ultimately ends up I'm going to give you a guideline on that, but ultimately you end up having to put the right part in to get rid of the wobble. And it's not easy to know what the right part is. So this wobble thing, what is it? Well, it's basically rotational moment of the pendulum. So you know what the pendulum does. It's supposed to swing back and forth from left to right. But what happens with wobble is the pendulum itself actually rotates along the axis of the length of the pendulum. And that resonates with the suspension spring, and you just end up with a big mess. So sometimes you do have to fabricate a replacement. And if you do, here's how to do it. The one on the bottom, what I show on the bottom left there was actually a picture I took of the spring before I actually cleaned up the rod, which I should have done before I fabricated it. But live and learn. In the end, it was all fine. But so what I do is I start with 1/16 inch mild steel, which you can get from McMaster-Carr, I think is the go-to source. They're the best. They have a 4140 alloy 1/16 inch rod. Man, this stuff is hard to find. I couldn't believe how hard it was to find this stuff. I actually found it at Airgas and Eastwood as well, mild steel for welding, but it was kind of rough, let's say. So then I went to the McMaster car catalog and found a very inexpensive solution there. So I would strongly recommend you avoid drill rod, even annealed, because when you go to bend it, it may not survive. After all your filing, you'll just break it off. That's not fun. So you take, as I show there, you file off half the thickness to the length you want. And I mean, the lengths could be a number of things. It's easy to just copy another spring if you have it, but you could use it. That's not a really critical variable. So you can play with that if you have. One of the shortcuts, of course, is to grind it with a Dremel first to rough it in, and then you can file it and clean it up with a flat file to give you what you want. And then you go out and buy some 003-inch shim stock or spring, blue steels, which you can still buy at Time Savers and even on Amazon if you want to. You punch it as shown here in the bottom right, and then you bend up the part that you just filed and close it over, and you're done. And you can squeeze it with a vise if you want to get a tight fit, but that's all to it. And you end up with a nice looking. First one you make, will probably screw up. Next one, probably be 100 times better. So as with any of this stuff, takes a little practice, but it's usually not too bad. So here's a summary on suspension springs. I would stick with 003 or 004s only. The rolled flat ones that are the replacement rolled flats are terrible today. They used to be nice, but they're no longer. So you really can't buy a good rolled flat style suspension spring. Start with 003 by quarter by 1.375 if it's missing, or if you don't know what in the world to do, because that one seems to be real common. I do know that on the mini Ansonia mantle clocks, they went with a thinner one, so it's around 1.875 wide. And 004 there, you could actually use the feathers that you can get from Mile High and others. And Gilbert, again, 003, Ingram, 003. On the New Haven time, I just got a New Haven time and strike in recently that actually had a 004 by 187 by 1, and that worked just fine without wobble. So there's a couple of examples if you're missing or don't know quite what to do, and you should get pretty good results with those. So if you want to just use a supplier replacement, of course, that's up to you, and that's fine if they work and they don't wobble. And if they look good in the clock, and if the dimensions give you the pendulum length you want, and still have the adjustment to get it in time. Okay, now we're on to verges, which is my least favorite subject. And it's my least favorite because back when I first started doing this work, you could buy a nice verge. Can't anymore. Or maybe you could stumble upon one that's nice. And often the best verge you're going to find is the one that's on your clock to start with, but sometimes not because it's been replaced. If it is a good quality verge, you can often polish out the wear. Some folks like to move the escape wheel. I guess that's okay, but it isn't always possible. So often the saddle holes are really worn out. You can fit an oversized pin often to compensate for that. The worst case, you can change the saddle or rebush it if you want to really go that far. Often crutch wires are loose. They can often be tightened. The verge may just plain old be missing. I've run the clocks come in with no verge, and then you have a little engineering problem to deal with. But so why not just replace the verges? Well, there's a little bit of a problem these days. And the problem is there's way more poorly made verges out there than ever. The saddles are often I'll show you pictures of this, but the saddles are often misaligned. Verge faces I've actually seen some where the relief angles were backwards. In other words, in the assembly of the verge, they actually took the raw material, cut the relief angles, and then bent it backwards. It was the wrong way. So it didn't work. And I'm not talking about half deadbeats here, folks. I know the difference. I'm telling you, these things are junk. Now, back in the day, PM used to make really nice verges. And I don't know if some of you folks might remember PM Clock Supply. And it seems to me that Time Savers, since PM's gone out of business, Time Savers has bought out all their stock. And often if you buy their miscellaneous kits, you'll find some of the PM parts mixed in with the cheap Chinese parts. So And I don't know, maybe they're Indian too. I can't tell you, but here's a comparison. On the right's a PM quality verge. Unfortunately, I still have some of these verges left over from when I bought kits back in the 80s and 90s. So, I can still go back to these things. But on the left, you see what you typically get today. You get these verge faces cut with enormous, horrible burrs on them. So you have to do a lot of, post-treatment. The steel is really poor quality. It's hardened all the way across the length, so you almost can't make any adjustments without breaking it. Often the relief angles are backwards, as I said. The brass wire is often rather large, which makes the tight bends you need on these clocks a little tough to make. The saddles, I can't say enough about how much I love these poor saddles. You get the dimple that's out of center with the hole. And they're often riveted on with a rivet that's so big. I've run into some that were riveted with a rivet so big it would interfere with the escape wheel. I had to cut it down. So just all kinds of weird problems with these things. Whereas the PM quality verges are beautiful and unfortunately not so available anymore. So what do you do? What are we going to do? So here's a strategy. If an incorrect replacement is installed, go out and get one of those kits. They're not real expensive. I mean, I think the last time I bought one of their kits, I got it for like 13 bucks. It's like cheap. And then you try to fit a verge and find which one works kind of the best. If it's a PM quality, you're done. If it's not, if it's Chinese quality, then you might, if you got the skill, copy it and, make the components out of quality. You can actually use 0.3 2-inch precision 0.1 tool steel, which I've done many times, and end up with a much nicer verge than anything you can buy. Of course, if your original verge is there and available and just needs to be cleaned up, do that by all means. By no means should you just replace a verge because you're doing work on a clock. You can almost always salvage an original. There's almost always a way. There's a lot of thickness in those originals. I think they were close to 1 millimeter thick. So even if you have to, grind them down quite a ways to get the wear out, you'll still have a usable verge. And of course, you may have to adjust the verge, lock and drop after you've done and make it work, but it's doable. So the one thing I do quite a bit of, though, on these verge pins and on the clock that's a subject to this particular study, I end up making a new pin. The original was 0.52, and often it doesn't take much. This was a really bad one, and it only took an 0.56 to clean it up. So, and here you can see the original pin was really in bad shape. I can understand why this thing was so rusted out and corroded. It didn't make any sense. I just scratched my head and moved on, but putting in the new pin was a piece of cake. Cut it off, clean it up, put it in. Okay, so let's talk about my favorite topic with respect to mainsprings, which is the damage they do. And the two areas of damage you'll run across with these things, of course, other than the bushings, is the worn wheels and trundles that get beat up. And even with the right spring, trundles can get beat up quite a bit. Folks that sometimes, back in the day, everybody seemed to oil the trundles to, for example, decrease the noise and the strike around the fly, but that doesn't really work. It's not a long-term fix. Kind of goes, the solution goes away, and what is remaining is that oil attracts dirt, which then embeds itself and causes wear. The trundle replacements are going to happen. You're going to need to do it, and if you don't, at some point down the road, you're going to have some real severe teeth damage too, and a very noisy fly if the trundle wear occurs there. So, and here we can see with the wheel damage, and this is interesting because it varies. Some of these things are real bad. This one in the picture wasn't actually as bad as, I couldn't find a good one for the picture, but I've had some that were worn 2/3 of the way through the tooth. And then folks talk about, well, you just reverse the wheel. Well, if you've got a wheel where the teeth are worn through 2/3, you're not going to want to reverse the wheel. That's a short-lived repair. So you're going to have to do something about it. Well, it turns out that in the 70s, and this is something I alluded to earlier, in the 70s, the 3/4 by 0.18 by 96-inch spring was real popular. And there was this belief that all you had to do is go buy a whole stock of those and throw them in your clocks and you're good. Unfortunately, you ended up with a lot of wear as a result of it. And often you were replacing a spring that was 015, or even I've seen some cases where 014 springs were replaced by 018s, and not good. So always be aware of that. We'll talk more about mainsprings, but I found that this replacement from Time Savers of the 11507 is not a bad solution. It really is it's a good wheel. It's made generally pretty well, and it fits Gilbert, Ingram, and Sessions. Unfortunately, it doesn't fit Ansonia and New Haven's. Now, if somebody put the right springs in, chances are the Ansonia and New Haven main wheels are not worn to start with. So, you know, that might not be a problem, but I've also had to make new wheels for those too, because I found 018 springs in them. So I can't believe it, but they're, and you know, you look at it and you say, why is the plate bulging around the main wheels? Oh, because it had a 5/8 spring in it before, and now it has a 3/4. Oops. So, and on the right here, actually, you could see this is an example of a wheel that was cut here in the shop, that, you know, the tooth profile is not an exact copy of the one on the left, but it worked beautifully. So, and another thing to watch out for is often the clicks in these on these assemblies have slots cut in them to accept the retaining spring that, you know, pushes up against the click to allow it to engage with the ratchet wheel. Beware, often, and I mean, unfortunately, way too often, those clicks wear, even if they're steel clicks, they wear, grooves wear in those, and those things, and then they seize up during the winding, and they allow the the spring to unleash its terror onto your customer's hands. So always check that slot. It's not a real difficult thing to get to clean that up, and often can be done with something as simple as a jeweler saw with the right thickness blade in it, and you can clean that up. There's other ways to do it too, but that often works well. But do check it, please, because I've seen way too many instances where there was a groove and it didn't actually become a problem during the test run, but later on it did. So, and also be careful of bulging clicks. The bottoms of these clicks often bulge, often both sides bulge, because of the force of the spring. And again, you end up with this thing where this big bulging click, just the tip of the click is bulging, and it interferes with the wheel itself and seizes up and causes the spring to release onto the customer. So, and also I recommend replacing the springs, the rivets in these. Many of these clocks use brass rivets, and you get them and they're wobbling all over and loose, and it's just as easy to replace it. So you probably should do that. Trundles, you know, everybody has had to deal with this, I'm sure. And if much I can say here that you're not familiar with if you've worked on an American clock. But if you can see, I mean, if you could see a polishy kind of an effect on the trundle, it's probably fine. You probably don't have to worry about it. If there's a little bit of wear, you got to use your judgment. But I've seen these things worn halfway through, and no, those are not acceptable. Some suggestions on how to make the trundles. I have this thing called a work sharp that I use for a lot of trimming and filing and sanding. It is a wonderful tool. You could use it for everything from this to, you know, sharpening your lathe tools to a bunch of other things. They're not that expensive, and man, I must use that tool 10 times a day. It's just so handy. And I'll show you some examples of some other things you can do to cut the trundle wires. This is an interesting one that I found from Doc Fields on the NAWCC message board. He made this little tool and fit up his Shoreline lathe with a cutoff tool from his Dremel kit, and used this to cut precisely the same length. My only warning with this is keep your eye on this thing when you cut through, because it's going to want to grab the wire. So what he did is he used a little, instead of using, say, a pair of pliers, you just put a little alligator clip on there to hold it. So it was an interesting tool. It seems like a lot of effort when something this simple could work too. What I do, this is the way I do it actually, is I'll take a piece of 12014 rod, which for those of you who know the alloy, 12014 is steel, cuts like butter. It's an alloy of soft steel that actually has a lead, kind of traces of lead in it, and that lead makes it extremely machinable. What I'll do is I'll take a 3 to 4 inch cutoff length of it, maybe a quarter diameter, maybe less, even 1/8/7 works. It's up to you. And drill the end with a drill that's 10% over the OD of the wire stock I plan on using for that particular trundle. And if you work on these clocks, what you'll find is a lot of the trundles in these clocks have the same size wire. There may be 2 different sizes in a clock. So that it means that with one rod, because you can get 2 different sizes, you have 2 different ends. So you drill to the length of the trundle that you're trying to replicate, and then you can basically use this to hold it while it's being cut off, and then sand it down with the same tool without removing it from the tool. This morning I made some trundles. I made a whole batch in like 5 minutes using this method, and the work sharp. So it goes real well. And the same method you can use to replace these pins that you often find in both German and early American clocks too, and it makes quick work of it. And by the way, you could also use it on our little guy over here to the right, where we had to reinstall that pin that we talked about earlier. So it helps hold the wire vertical while you're tapping it in, and it makes a really quick work of it. You might ask, well, why don't you just use brass? Well, you could, but the problem is if you start using it to, drive anything home, the brass is going to give against the steel, and it's just going to, you're going to lose dimensionality there, or maybe even get your pin stuck in there. You can't get it out. So, all right, here's our trundle repair. This is the approach I use. The first thing I do is took a cutoff, an old 1-inch brass cutoff, and drilled it out so that the bottom of the bottom shroud would pass through the hole that I drilled, and also the arbor, of course. And just used a piece of 1/8/7 brass rod, turned it into a hollow punch by drilling a hole in the end to clear the pivot. And here's another example. What I say when you're trying, I've seen examples online and so forth, where, and even in the shop with apprentices who want to use the punch kit, the toolkit for watch repair, and use that as a hollow punch. The problem is it's steel, and it's hard steel, and it will mar the shoulder of the pivot. And so, or the shoulder of the arbor around the pivot. So I don't recommend using steel to drive steel. Use brass to drive steel, and it'll give, and it'll prevent you from doing damage and marring on the pivot or its shoulder. So it's kind of a good idea to avoid the steel on steel thing. And so you can see the process here from left to right. You drive the wheel. I drove the wheel up by tapping on the brass hollow punch, remove the trundle pins, and now I'm ready to go. And then I select the wire. In this case, it was actually 29 diameter wire, which was in the pinion wire assortment that I got from Time Savers. And by the way, you can still buy all these things. Just go to Time Savers and search on pinion wire. They've got every size. And it's really, I don't think there's a size I've ever not been able to find that was in their, kits or assortments that they have. So it's a nice set. Okay, so that's it for trundles. Now we get on to the main wheel bushings, which are often neglected because people think that they have to rebush them with big Bergeon bushings and it's too much trouble. So no, you don't have to do that actually. There's lots of problems that can arise from the main wheel bushings being loose, including, gearing issues between the main wheel and the second wheel. Big problems there can get you in a lot of trouble. So, and some of these things wear out horribly. These examples that I'm showing here, these were not actually that bad, but they were just too loose for me to tolerate. And unfortunately, I can't in pictures show you what this looks like. I could have done videos, and I wish I would have, but these were they were quite loose, despite the fact that they weren't as bad as some I've seen. So these are the befores. This is what happens when mainsprings are too strong, or these bushings and bearings have never been addressed. So what we did here is we just knocked them out, just put them on a stake, and you can make a stake easily out of a chunk of brass, cut off brass, and just drill a hole in it, or put it in the lathe and turn it, which is a little bit easier and more secure than trying to drill free-handed. So anyway, you drill up your little, you make up, or maybe you've got an appropriate size anvil with some holes in it that will accommodate this, but it's not real hard to knock these bushings out. You could usually do it in one tap. Do make sure that whatever you're using as an anvil to pass the bushing through, though, make sure it's tight, relatively tight to the bushing, so that you don't bend the plate in the process. So out they come, and actually we made a few of these in our class, and showed folks how easy it is to make these things. So you knock them out, you turn them on a lathe, rivet them back in real simply. Remember what we talked about. If you polish the end of the hammer and finish it off with something like 2500 grit sandpaper, or at that point it's actually polishing paper, so that you have a nice smooth hammer. And by the way, I do have one hammer that I keep absolutely clean, another hammer that I don't care, because I'm just going to use it to hit things or whatever, hit on a punch or something, and I don't care if I mar the end of the punch a little bit. That one's fine to not be polished. But anything that comes in contact with a clock part, plate, bushing, whatever, I use the polished hammer on it. So then you broach them to size, and we've done this in our workshops. It's real easy. These bushings were a mess, and now they're great. So, and you can see here some examples. This is the after, same pictures we showed earlier, and much tighter. And they'll last a lot longer now. This was an interesting one I wanted to call attention to. Here was one where it had worn, it didn't even wear in length. It was actually, or should I say in width, the hole itself was actually still tight. And there was no reason to consider replacing this bearing until I noticed that I had an interference between the rivet, the rivet that holds the click down, and the second wheel. And this really doesn't show it real well, unfortunately. But if you run this second wheel over to its end of travel on, you got end shake on these things. You run the thing to its end of travel on its end shake, it literally ran right into that rivet and stopped the clock. And so apart the clock came, and sure enough, the main bushing, main wheel bearing was actually worn through its length. Now that was a new one. That was a cute one. So I call your attention to the fact that you just because they look good on width doesn't mean that you don't have issues with them. And so we went ahead and replaced that bearing, and here you can see I actually used my finger to push up on that second wheel arbor so that it was at the end of its travel, and sure enough, now it clears. So we're good. But that was elusive. That one caught me off guard. So broken mainsprings, we're going to talk about, move our way now towards mainsprings. Here I show in the watchmaker's lathe, I mounted the second wheel, which had experienced collateral damage from a broken mainspring, and you can see there's quite a bit of angle on that one. And you should always look for these. Also look for trundle wires to be damaged. This one didn't, surprisingly. But actually what happened here was the mainspring broke. So it didn't really torque the main wheel. And as a result, the trundles didn't get damaged, but sure as hell did bend the arbor on the second wheel. So I was able to straighten this one with my fingers. It's important not to put pressure on the wheel when you do that, because you could loosen it up. But it yielded very nicely, and it runs true in there now. So back to mainsprings, as I promised we would. It's always important to analyze the mainsprings in these clocks, because what you may have in front of you may not have been what was supposed to be in there. And sometimes you have to do a little bit of mini engineering on these things to figure out what they really need. So I would really avoid 3/4 by 1/8 by 96 mainsprings. There are some exceptions. The Sessions 2-train Westminster and the Seth Thomas number 42 actually came original with a 1/8 thicks, and 96 seems to be the length. So those work there, but I would never use anything thicker than 0165. And it turns out that Time Savers figured this out after enough customers complained, and they actually stock a very nice German-made spring that fits the bill here. The original manufacturers, if you look through the Trandeli books, often specified 017. But remember, the newer steels, brand new steels, The treatment of the steel is improved over the originals, and the material itself is better. They're often stronger to start with than the original springs were. And you will not have a problem if you use 0165 instead of 017. In fact, we're going to talk about it. You could go a lot thinner and still be okay. I've actually used 015s in some cases where I just felt like the 0165 was too much power for a particular movement. I like the German-made springs. The Chinese and the Indian springs are often sloppy. The loops are often made with rivets the size of a eraser, a pencil eraser. They're horrible. They're sloppy looking, and I just don't like them. So, and also the India springs also I've noticed have really distorted centers. And I just don't know why the Germans are the only ones that seem how to make a good mainspring. I just don't get it, but it seems to be the case. The width is important too. Please don't neglect that. If you use a 3/4 where 11/16 was supposed to go, you're going to get the wear that you see on the right there, where the main wheel actually got hogged out from the spring grinding against it. So Reindel has some of the publications do include the original thickness of the springs. And my recommendation, always go a little lighter. Never go a little heavier, ever, ever, ever. You should never put a spring in that was thicker than the original, ever. But going a little light, completely fine. Here's a table that I put together. You can use as a reference. We won't spend a lot of time on it now, but I do want to point out a couple of things in this table. The Seth Thomas 89s, it turns out the Time Savers does have a part that's almost an exact fit to the original, but it's 016, it's fine, totally fine for this. Another interesting one was the New Haven 303 to 337. Those of you working a lot of these movements by now know that this is a kind of a miniature version of what most American clock movements were back then. Conover, who I really have a lot of respect for, strangely recommended a 3/4 inch thick spring here. And I cannot get a 3/4 inch spring to fit. So I backed that off to 11/16 in my recommendation. And the longest spring I can find is 108. I'm sorry. There's some Korean made springs that are Korean clock springs that are longer. But you'd have to cut them down the fit. And the 108 seems, or 96 or 108 seem to give you plenty of runtime. So for a 126 original, I'd go at a 108 is probably fine runtime. They also have, it turns out, an 014 as an option too. So if you feel like, gee, this thing's looking like it's kind of worn, I guarantee you an 014 will work fine. So, and the rest you can kind of look at as you need to. This is an interesting chart that I kind of adapted from something that was on Abbey Clock's website, Mark Hedricks. He's an interesting guy. He's got a lot of interesting observations. You might want to take a look at his site. But what he did is he actually reported that he got better timekeeping, actually the best timekeeping, when he went to an 012 inch thick spring. Now, I can't claim to know where he got the spring or how it fit or anything else, but this is an important observation, because it turns out that the strength of a spring goes as the cube of its thickness. So for example, if you're going to use an 018 over an 015, the difference in strength is 018 divided by 015 to the third power. It's not linear. It is linear on thickness of width of the spring, but it is not linear on the thickness of the spring. So even a little bit of too thick spring will give you a spring that is way stronger than you need or want in your clock. So in fact, I don't do the math on it, but I recall that 018 over 015 is like double somewhere close to double the strength. So anybody who wants to, you can check me on that and report back at the end if you want to do the math on that, but it makes a big difference. So why in the world would you ever use an 012 spring? Well, I'm not sure you'd want to, but the point is it supports the whole idea that going a little thin is never going to be a problem. Going a little thick is always going to be a problem. So mainspring hygiene is important too. You buy a brand new spring and you look at them, they're filthy. You know, for some reason, they wind them without cleaning them. Well, obviously we know the reason, it's cost, right? They don't want to spend the money. but you end up with little chunks of crud from when the ends were hardened, or sorry, not hardened, but when the temper was let down on in order to be able to punch them and form them, and all that crud is still in there, and you really don't want it in there. So I recommend unwind your spring, clean it up, put it back in. Always use mainspring winder. I've seen some crazy examples of people winding these things without mainspring winders. And well, I mean, it could be a painful experience, frankly. So, and always use gloves, use leather gloves. They're cheap. You can buy them anywhere, to keep your spring in control. I mean, you don't realize it, but when you start winding these springs and you're holding them in you're holding in a hand, you could very quickly end up with fatigue in your fingers that, will result in loss of control. And having a spring winder is really essential. And speaking of which, I've had a little recommendations, or at least experience with these. And I can't say that, again, it's a tool. Everybody has their opinion. I'm not going to criticize one person's choice over another. I'm just going to tell you what I've run across. I started out with a Webster years ago, and I couldn't get rid of it fast enough. And the reason, it was basically a well-built tool, except the chuck was just cheap as junk. And I could have sat there and remachined the chuck and readapted it and so forth. But they had other problems too. And the other problem was the hook and loop supports were not adjustable. So you were stuck with one length. And I mean, if your spring was bunched up to the point where you had like, for example, you try to wind one of those Korean springs, and the thing bunches up and you can't fit it in there. So the loop is running up against the outside of the spring. You just can't fit it. So I decided I had to find something with an adjustable hook and loop. And sure enough, Keystone had just the thing. And I've been using the Keystone now for 20 years. I like the fact that it's rigid, that the barrels are substantial, which was, by the way, another weakness of the Webster. I once tried to wind the Seth Thomas Sonora, big mistake on the Webster, and oh my gosh, it was scary. And when I was done getting the spring in the little mini holding barrel that you see there, it was distorting. I was like, I got to get this thing back in the barrel like right now before something lets loose. Whereas on the Keystone, I had better luck with much more robust barrels. So, and it has the hook and loop that's adjustable, but it does not have a ratchet, which is really a bummer, because all you have is that slide bar to hold back your spring. And when you get used to it, it's okay, but it can be challenging, especially with the fact that the winding arbor also slides all over the place. And so you have to be conscious of that. You could push the spring in or out of the winding, and then the thing could blow up on you. So you have to be aware of the tool's weaknesses when you're working with it. And it does come with a rear arbor support, but I really didn't find that real convenient. You have to remove it and put it back on, and with screws and stuff. It's just, I don't find it to be that useful. But on the whole, I use this tool all the time. I looked at the Ollie Baker. I never used it though. It looks pretty cool. I like the fact that it uses the little mainspring winder keys as the lead. You use these things for the letdowns, and you just pop them in and use it to wind. But the problem is, if you're working with something that's not the original keyed arbor with the flats on it, it's a little bit like, now what do you do? So anyway, I like the fact that the Keystone has a chuck, so that's an advantage, but I really do like the ratchet on it. I got to tell you, and the AccuWinder from Reindel looks like the same thing. And with either of these right now, good luck, because they've been on back order, I can tell, for like 6 months. So you have to get on a wait list to get them. And I think, if I'm not mistaken, that the Keystones are still available from stock. Certainly Mile High has them here locally. So here's a couple of miscellaneous quick tips. On the drop and count lever springs, I recommend 012 to 014 wire, the spring brass. I've seen some of these things come in with 018 on them, and you just don't need that. 012 to 014 spring brass wire works fantastic, and it's always my go-to on these things when they're missing. The flat style mainspring clamps are really cool because they don't take up a lot of room and you can squeeze them in easy. Mile High has them now. I got to tell you something. I hate to say it, but I've actually had one of these things break on me. So always be aware, any tool you use can have its problems. And the one tool that I find is really handy is this little verge adjuster thingy down at the bottom here. That little guy comes in handy because you cannot make good adjustments to verges without minute, control. And if you don't have that minute control, you're going to go in there and start beating on it with a hammer or something. You're not going to be able to get anywhere. You're going to go back and forth until finally you break it. So this tool really is the cat's meow for avoiding problems there. So anyway, anybody who has ever worked with it before, I'd be interested in your feedback on it too. So our subject clock, here's the summary of all the things that were changed on it. We had arbors that needed to be remade. We had pinions that had to be remade. Both clicks were just junk. The main wheels were just not worth salvaging anymore because of various issues. In one case, teeth wear, in another case, the surface wear. Main wheel bearings, all kinds of things in this thing, and not to mention all the bushings and so forth. So it's all listed there on the right. Took quite a bit of work, but now the clock runs reliably. Geez, that was a lot of work to get there, but it really felt good seeing that clock run. Oh, and the main springs too. Those springs were just the wrong size. So, okay, that's one of the things I want to point out here, although we're all pretty much done here, is I have a shout out to Stephen Conover. Before Stephen Conover came into focus, there was no information on how to repair American clocks. There was nothing, absolutely nothing out there. And now he's got an entire series dedicated to this. And all of these references are available on his Clockmakers newsletter site. I used to be an avid reader of Clockmakers newsletter when it was actually still in publication. And I'm going to tell you, it's some of the best stuff out there that's written on these clocks. And, you can go back and buy the back issues if you wanted to. They're all available and they're all really affordable. And so, yeah, take a look. They're good. And he's even got a thing on building an American clock movement if you want to. So you can see, because you will have to make replacement parts at some point. And if you understand what he's publishing in the American clock movement little booklet, you'll have some insights on how to conquer some of the problems that you're almost bound to run into with these things. So that's what we had today. And I'm happy to take questions if anyone does have any.
Anybody have any questions? Well, I don't see any. We appreciate you taking the time out of your morning to come and speak with us in chapter 24.
Sure. Now we recorded this, right? So folks can go back and review things if they want to, right?
Yes. Yes, we did.
Great. If anybody has any questions on any of this stuff, feel free to send me an email, and I try to answer my emails like as fast as I can, but 24 hours generally at the worst.
Well, all righty then.
Thank you.
Well, obviously that concludes our program and therefore our meeting today. It was good to see all of you. Hopefully the rain is holding off now so you can get your car without being washed into the next county. We will see you first Sunday of June. First Sunday of June. We'll be here. Okay, thank you.
Thank you all. Bye, everybody.
Bye, everybody.